Well, good morning and good afternoon, everyone, and welcome to Hydro International's Industrial Stormwater Treatment webinar. We still have folks joining in, but we're going to begin anyway. My name is Kim Jordan. I'm the Industrial Stormwater Manager for Hydro International. I've been with Hydro for approximately 8 years. I've held multiple positions. I've been in the stormwater industry for about 20 years, whether it was the pre-treatment or post-treatment area. And what I'm going to do today is walk you through, there's, just to start off, there's people from across the country and Canada, and there are, they come from many different areas. Some are students, some are seasoned professionals, so it's a broad spectrum of attendees. So I'm going to start off by talking about the basic permits and what types there are, and explain what the industrial permit is. So this is kind of an outline of what I'm going to discuss today. Then I'm going to go into giving you a little background about Hydro International. Even though we've been around for quite some time, there are lots of folks out there that have not heard of us. So I like to give a little background as to what we do and the importance we play, the important role we play cleaning up water here and actually around the world. After that, I'm going to talk about some of the products that I use for industrial treatment. I'm not going to be discussing all the products that we have and all the products that could be used for industrial, but I'll be discussing primarily our filters and some chemical applications. And I'll have a case study of each one, or at least a project outline explaining what we did, the drivers of the project, the results, and so on. So I'll do that for each what I call case study. Then I'll talk about post-installation maintenance, pollutant removal testing. I'll actually be talking about pollutant removal testing throughout the presentation. That's one of the benefits that Hydro offers, and I'll be touching on each one of these case studies. And then I'll quickly discuss your next steps. Now, bear in mind at the end of this presentation, there's a survey. There's always a survey, right? There's going to be up to 10 questions, a very simple survey. Please take that survey, fill it out for me. It really helps us focus on our audience, and it helps you in the future on future webinars. So even if you cut out early, please take the survey. It's going to show up either way. So just jump right in, talk about stormwater permits. There's multiple types of stormwater permits. For those that aren't familiar, they come from the Clean Water Act or the NPDES. Essentially, the permits that are out there are construction permits. They're typically 5 acres plus. There's multi-sector general permits. You'll hear me call that the IGP, and that stands for Industrial General Permit. There's acronyms for everything, so I'm sure most of you are aware of that. And if I gloss over some, I apologize. I'll try to kind of spell out each acronym as I go. There's the MS4 permit, the Municipally Separate Storm Sewer System. And then there's the infamous individual permit, if you're lucky enough to have one of those. Obviously, what I'm focusing on today is the multi-sector general permit, as I say, also the IGP. So there's 29 industrial sectors in the multi-sector general permit, hence multi-sector. Again, IGP is what I call it. They are pollutant specific, and they're based on your SIC code primarily, but they focus on what, they are tied to what you do, what kind of operation you have on your facility. So who are these who falls under the stormwater permit, the industrial stormwater permit? It's a very broad umbrella, manufacturing, processing, maintenance facilities, garages, transportation facilities, mining, landfills, transfer stations, a bakery. Literally, it's a very broad net, and more facilities are falling under the industrial permit as time goes on. So that field of who is the industrial permit holder, or who should be holding an industrial permit, is growing. There are some exemptions. Just want to mention what they are. And essentially, if none of your processes come in contact with rain, you can apply for an exemption. Or if you have zero discharge from your facility, you can apply for an exemption. So there are, if you're lucky enough, there are some ways around it, as long as you don't discharge to a receiving water body, an MS4, or you have no contact with rain. So there's differences for each permit. I'm not really going to get into the differences, but what I'm going to talk about is, why it's needed. So a municipal general permit, or the MS4, they need a permit to operate. The construction general permit is a permit, and they need the permit to actually do construction. To begin construction, they have to have that construction permit. And the multi-sector industrial general permit is different. They need a permit so they can discharge water. And the WOTUS that you see there is Waters of the United States, or an MS4, which is a municipally separate sewer system, storm sewer system. And the basis of the industrial is they actually have a very set effluent limit that they have to achieve. And I kind of dash line this, and these are called many different things. They're called benchmarks, they're called NALs, they're called discharge limits. So I could use a different phrase each time, and I apologize if I do. I am actually in California, so to me they're known as NALs, and NALs stand for numeric action limits, but they all kind of mean similar things. This is what you're supposed to achieve in your effluent discharge from your site. So that is your goal. So I'm going to take a poll. Bear with me for 1 second. I'll pull this up. It's a very simple poll. And it's basically asking if you've ever worked on an industrial site. So I'm going to launch this, and I'll give you 10-15 seconds to fill it out. So I've launched it. You should be able to see it, and just respond. Check whichever box. You only get one box that you can check. I'll give you a few seconds to fill it out. People are still voting, so I'll leave it open for another moment. Okay, looks like everyone's set voting. Now I'll share this poll with you to show what people have said to this poll, or how they responded. So 58% said yes, I have. 19 no, don't work in the industrial market, and 23 have other colleagues that are in this market. So essentially, over 80% either have in their company or organization they do work in the industrial market, and 20% are interested in what's going on and potentially might be working in the industrial market. So I'm going to hide that poll and move on. So I just want to give a mention about TMDLs. TMDLs are, the TMDLs stand for total maximum daily loads, and these are essentially watershed-based objectives that are set. They're not everywhere. They are kind of more in the water body that your discharge goes to. So you may or not be under a TMDL. These levels, if you are under TMDL, you know, or you may know, you should know, that you have to meet these TMDL levels. Doesn't matter what permit you're under, whether it's construction, industrial, MS4, you must meet these. And certain examples of TMDLs are sediment. The ones I hear about most, nutrient. I moved to California from Florida, so nutrient, the green tides that you see and the green slime in the rivers. This is a very big player in Florida. Bacteria is very large. That's one I hear about a lot. Metals is also another one. I'm here in the LA area, and copper is, I'm in the TMDL for copper area. So you have to pay attention to these. Trash is another TMDL. So there's all sorts of different TMDLs depending on where you are. And the pollutant of concern. And essentially what a TMDL is, I mentioned total maximum daily load, but that's essentially the maximum load that that water body can handle. So that's why they're so important. Anything beyond that, the water body can't handle it, and it creates environmental issues. So just to give you some background on Hydro International, you know who we are and what we do. We operate in 33 countries, so we're across the globe. We have 200 plus employees focused mainly on stormwater and wastewater. Everything we do is about water. Our headquarters is based in England. Here in the US, our stormwater division is in Portland, Maine, and our wastewater division is in Portland, Oregon. It's actually in Hillsboro. I'd say Portland, Oregon, just because it sounds really cool. It'd be from Portland to Portland. So the basic concept here is no matter where you are, if you have a project anywhere in the world, Hydro can help you. So that's what we do. We're growing all the time in different areas that are focused on water quality. Our capabilities, we do stormwater management. We manage the flow and manage the storage, and we also do water and wastewater treatment. We do flood protection, that's part of stormwater management. We do screening and treatment for CSOs. Obviously we do industrial stormwater, which is what I do. Hydrometry, monitoring, and data analysis. We don't do that here in the States yet. If we do, it's in our Portland lab. We do this in Europe and other places, as well as the water engineering and resource management. We don't really do that here. When I say here, I mean North America. We do it in other places throughout the world. It is part of our business, and a growing part. Industrial focus. Well, Hydro, we've been around for almost 40 years. So we have a great deal of experience. We have thousands of products installed. And, when it comes to the industrial, it says we've been doing this for over a decade. Well, guess what? We've been installing treatment systems in industrial facilities for probably 40 years. We just weren't aware of it. We weren't really, it wasn't something that was on our radar because we were focused on construction, but our products are used in the industrial sector all the time. It's just becoming more and more prominent, and we've taken sharp notice on it because of the regulations tightening. So, metals manufacturing, waste, recycling, transportation. I mean, we've been in the transportation market for 40 years. So energy and quarrying, these are all areas that we've played in for a very long time. So, and the fact that we've been here for 40 years, I mean, we're one of the oldest stormwater treatment companies in America, really. And we're installed in industrial facilities across the country. So one of the things we're extremely proud of is our lab, our world-class lab up in Portland, Maine. So this was developed in 1996. It's one of the largest manufacturer-owned testing facilities in North America. And here's one of the plugs. We do our pollutant removal testing there. So what that means is we take your stormwater, your representative stormwater, and determine if our products can treat that to meet your specific discharge levels depending on where you are. And those levels, again, they'll vary depending on what state you're in. So we offer our pollutant removal test kits. They're free. And what we do is we take your water, ship it back to our lab, and do the testing. But we also do a lot of other testing there. We do product development. There's a great deal of testing that's required to meet state regulations. It seems like every state has their own regulations. So having our own lab is really beneficial, not just at helping in the industrial market, but throughout we do wastewater testing there even still. So it's not just for the industrial market. It's across our spectrum of performance. And we have affiliation and collaborations with lots of other entities across the globe. And the benefit of this, what's the purpose of this for industrial? Well, essentially what we're doing is taking a requirement, whether it's whatever the requirement is in that area, and we're matching it up to our treatment products, and that's exactly what we do in the industrial market. So it does play perfectly into the industrial realm of, you know, our affiliations with all these companies. There is a good role for industrial. So I'll get into the industrial products that we have, and we have several products. I'm not going to talk about all of them, but what I can do is put them on a spectrum. You know, and I'll start the spectrum from the far bottom right. What you see there is our hydro dry screen. So it's a gross pollutant removal device, but it can also be a trash removal device. I'm in LA. Their trash is becoming more and more of an issue, and you know, you have to have a screening device. You have to capture 100% of the trash 5 micron and above. So this system is kind of an end of pipe treatment that can do that. It's also used to reduce nutrients in Florida, and it's also a TSS capture mechanism as well. So it's suited for many applications, and it's suited for industrial as well. It's just the markets that I play in are a little bit beyond the gross pollutant phase, but that's not to say that's the case everywhere. What I should have said when I introduced myself is that I've also been the industrial manager on the East Coast. I just happen to be on the West Coast right now. And for hydro, it's across the globe, but I also have seven regional folks that can help me out depending on where the project is. So not to get off track, the 2 systems in the center, so that'd be a downstream defender on the right and a first defense on the left. Those are both hydrodynamic systems, or what are known as swirling devices. If you're in Canada, they're also known as oil water separators, oil grit separators. There's lots of names for them. But the one on the right, the downstream defender, which is the second from the right at the bottom of the page, that's probably our oldest product that we have. It's been around really since we've been in business. So for nearly 40 years, it's our tried and true product. And I do use that in industrial applications. You'll see that here shortly as I move through the slideshow. But these products, these 2 swirling devices or hydrodynamic systems, are really good at removing floatables and settleables. The settleables down to about 50 micron. Once you get below there, once you get below 50 micron, it gets a little difficult to remove with this system. It can be done at a little bit lower level, but for the most part, 50 micron is where you are. If you want to go lower than that, then we move to the left. The bottom left is a picture of our Up-Flo filter. And I'll get into that because I use it heavily in the industrial market. So that's the product I'll be talking about. There's also, I'll call it a product, but really they're chemicals that we use that should be grouped in there with the Up-Flo filter to the left as far as the particle spectrum. But and I'll be talking about that as well, chemicals. But the Up-Flo filter is good down at small micron, can also remove dissolved metals. So it's kind of my workhorse in the industrial market. So it's the one I'll be discussing. So the first product is the Up-Flo filter. It is a CPZ media. So this is a media filter. And if you see this picture, the inlet, which is on the left-hand side, in the outlet on the right-hand side, there's a elevation difference, but this is the workhorse. This product has been around for a while, and I mentioned it's CPZ. So what is CPZ? Again, one of those acronyms, but it stands for carbon, peat, and zeolite. So in our filter, there's a mix. There's granular activated carbon, also known as GAC, which targets organics. For chemicals, pesticides, herbicides, anything organic, oils, it captures oils pretty well. We also have peat, and what peat does, it targets dissolved metals, zinc and copper. And then we have zeolite, which is it's manganese coated, and that's really good for TSS, iron, manganese, and ammonium in the form of nitrogen, really. So nitrogen removal. And actually, all of these are good at TSS removal. It's just that zeolite is a very, I'll call it porous and has a huge surface area. It's made from a volcanic ash, and it's just really good at TSS. So here to the right, the picture to the right, the blue, that's one of our filter modules, this blue structure. So if you pulled it apart, that's what it would look like. On the bottom, kind of, you can see how not the frame, but through the opening there, you can see like a mesh. That's a screen at the very bottom. There's green material. We call that Metalla, but it's flow distribution media. And it also is very spongy and it's thick. And what that does is it controls pressure on the media and also allows flow to be distributed evenly. And then the media itself is those two white slash tan wafers in the middle. Those are bags of media, the CPZ. And you know, that is this is a fluidized bed media. So, but that's the combination of what's in a cartridge. So at the bottom far left, you can see what our media would look like. That's a CPZ media. You can easily see the C and the P there, the carbon and peat. And then to the right, you see the nice white bag. That's a brand new bag going in, so it looks like very much like the one in the image. And then you see a soiled bag, and a pretty stark difference there. The soiled bag is black. But you'll notice on the black soiled bag, you can easily see a handle. So these bags, actually on the white ones, you can see them as well. So these bags have handles that you can just pick them up and maneuver them. And that was designed into the system for maintenance, ease of maintenance. It's not a heavy cartridge that weighs 200 pounds. They're bags that you can lift up, and they have straps to do so. This system was developed by Dr. Bob Pitt, the University of Alabama. Dr. Bob Pitt designed this system specifically for stormwater treatment, especially the media. He offered 23 articles focused on media for stormwater treatment. He also consulted with the EPA and developed a multi-chambered treatment train. And when I flip to the Up-Flo filter again, it's essentially, it's a single chamber, but it's a multi-chambered treatment train, essentially. I should just say it's a treatment train. And what I mean by that is the way it operates, there's small pictures up at the top here, kind of blow-ups. But the way it operates, it comes in from the left, you see an inlet pipe. The right is an outlet pipe. You also have a graded inlet on top. So water can enter through the inlet pipe or through the graded inlet or both. So it's a pretty versatile system. The inlet pipe is about 9 inches higher than the outlet pipe. And that 9 inches just happens to be the width, the thickness of the media bed that we have. So ideally, we keep this media dry between storms. But when water enters this structure, it goes into the sump. These filters are raised off the sump. When I say filters, these are the blue modules that I'm talking about. They're raised off the floor of the vault to create a sump. So you have settling taking place. On the bottom of these filter modules is a screen. So the second caption on the top, the teardrop looking picture, it just kind of shows a highlight of the screen. And what that screen does is keeps large particulate matter away from the media, keeps it from clogging, and also it's sloped at 30 degrees, so that screen pushes all the debris toward the center of the vault, where away from the filters. The third caption that you see, the third teardrop, shows the media bed, and this is a fluidized bed. So what does that mean? It's an Up-Flo filter fluidized bed. So when water goes in, as I said, it fills up the vault system, fills up the sump, and eventually there's enough pressure to push water through the media. And when that happens, the media actually swells up. And I mentioned the Metalla, the green material, it's flow distribution media, but it also helps provide good even pressure in the system so that when it swells up, we've got just enough pressure to have great removal. So too tight and you have very slow, really great removal, but it's extremely slow passing through the filters. And too loose, meaning the particulates can go right through the system and you wouldn't capture much. So the real science of it was having the right pressure on the media to operate properly. So the fluidized bed expands, and that's what the fourth picture, the fourth teardrop shows you, is the water expanding. And the filter bags that I'd shown you earlier, they actually do swell up and expand. The The next teardrop picture is it'd be the second one from the right at this point. When the storm subsides and this the filter goes back to its resting state, it actually collapses back down. So you have a swelling and a shrinking action taking place. And what that does is essentially you utilize the entire media bed as opposed to just using a surface filter. So you get much more longevity out of the system like this, and that's why we can simply use 9 inches of sand. So that's one of the benefits of the system. And as it goes through, there's actually a chute in the top of each one of these blue modules, and it goes around and connects to the outlet module. The outlet module is the one at the very end on the right that has the yellow, looks like a yellow hood on top. That yellow hood is actually a bypass system if we need to use an internal bypass. And then it goes into the outlet module to the outlet pipe and exits the system. Clean treated water exits the system. So that's simply the way it's set up. Now, there is one more picture I didn't talk about, the teardrop. It's the last to the right on the upper top there. And it's this 90-degree bend, and it's got a little filter at the end of it. That is a drain down. So we want to make sure that our media remains dry. So that filter actually drains down the water the last few inches to get it below the media bed level. So that's and accommodates that 9-inch drop I talked about. So and that's pretty much the way this system operates. It's extremely simple, completely by gravity, you know, and it's very versatile. And what I mean by that is the driving head to run these filters can be varied. Typically, we use 30 inches for this media to drive water through it. That's 30 inches above the media, but we could do it with 10 inches of head pressure above the media if we need to. How we would compensate for that would be adding more filter modules. So it's extremely versatile system. So I'm going to give you a case study on this. It's a metals company. It's an aerospace metals company here in California. Just the background is it had existing exceedances of metals. It was pending a facility expansion. They were putting in a brand new forge press. And there was also new regulations coming out in California at the time. So they were afraid of an increased risk of legal action because of new regulations, their expansion, and the history of having exceedances. So the challenge was they had high TSS, aluminum, zinc, iron, and copper in their effluent. And this facility was completely built out, had, you know, and this is very common for industrial sites, had very minimal space available for an above ground system. The solution, first thing we always do, we took sample water, a good representative sample, ran it through our Portland lab, did the pollutant removal test, I should say, and it was determined that the Up-Flo filter with CPZ proved to be the best performance system that we could use. So the Up-Flo filter integrated directly into the drainage system as shown. It was a below grade system. I guess you didn't see it, but essentially we could connect this directly into the existing drain system that was already existing on site. No power required to run this filter. And that's exactly what was needed for this site. The system would have been run over by construction equipment because of the expansion that was going on. The question was, would this system perform on site? And Up-Flo filter reduced the suspended solids and all the metals below the effluent limits. So you can read along there, 97. You know, we had excellent metals removal and brought it within their effluent limits. And in California, it was below their NLRs, or essentially back to benchmark. The expansion couldn't have supported an above ground treatment system. In fact, when we went out there and visited the site, there was storage, you know, structural beams and things on top of the treatment system. So there was just absolutely no space for an above ground system. Another case study for CPZ was the Port of Tacoma. This was an extremely large job at a very active port. You can see the cranes. It's a container terminal. So you have the long metal containers that they lift and put on trailers and move around. The background, Washington State has the most stringent industrial standards. I shouldn't say the most, they're very stringent, turbidity of 25, very low copper, very low zinc. So the challenge, they were under an administrative order to improve their effluent by December of 2014. So it was an active port, very difficult, minimal space. What space they had, there was heavy equipment being run all the time. So obviously below grade was the preferred system to use. This was on the bay, of course, since it's a port. Was tidal influenced. This has all sorts of issues from a hydraulic concern. Also, the seawater contamination of media. And the load itself, it was a huge area, heavily trafficked with turbidity, dissolved solids, just a heavy load. The solution, the port had pilot tested many different systems. They selected the Up-Flo filter. The filter was selected because of its ability to remove particulates, dissolved metals, and it also helps that it was an actual below ground application. So this was not tested in our lab. This was actually a pilot test. So the outcome, the Up-Flo filter reduced turbidity 75% and removed 60% of the zinc. So it was a good installation. With this equipment, you had to have aircraft loading. So we put it in an aircraft loaded system, below grade. Lots of challenges on this site from construction to operation. It was also, it was about 133 modules, pretty large system, 5 volts. It was written up in Stormwater Magazine, August issue of Stormwater Magazine. So if you wanted to check out an article, it's not specifically on the Up-Flo filter, but it's about the project and the port in general. But it lists a performance summary included in the article. Another application I use is the Up-Flo filter with membrane media. So you see the Up-Flo filter here, it looks just like the other one, except it has the membrane, essentially these ribbons hanging down. So what we've done is we removed the media, removed the screen, and modified the system to adapt membrane. And this is a picture of the membrane. The blue material is again, it's flow distribution media. It's not there, it's really there to hold the membrane apart and produce a flow path. So you can look, the picture on the right almost looks like a Gatling gun, but we've modified the Up-Flo filter modules to accommodate three membrane ribbons for each module. So the system really looks just like the other one. On the right, you can see the ribbons, essentially the modified module. On the left, the picture of the Up-Flo filter vault looks just like the other one. The only difference is the inlet and the outlet can be at the same elevation. We really don't need 30 inches of head to operate membrane media. They can flow at a much faster rate. So we have to give a little more care to designing the actual flow rate / treatment rate for this application. So it still has a sump, so it operates very similar. The water enters through the inlet, whether it's a drop inlet from the top or an inlet pipe. It has a sump at the bottom where heavy materials can settle out, and then it goes up through the membranes. The water is hydraulically pushed upward, so it's still an Up-Flo filter. It goes into the modules and across to the outlet to the right. So it's essentially a very similar setup. Just a case study on this one was a trash recycling / transfer station. This one was, all their facility, with the background, it was located on the bay, surrounded by bay, under a consent decree by bay keepers. So they had to improve their effluent limits. So that's the driver on this. So the challenge was the facility had pretty good housekeeping, but yet they were still over on all their NALs for TSS, zinc, copper, aluminum, and iron. Some by as much as 7 times the permissible limit, their NAL for California, or benchmark. The property, as usual, completely built out, bordered by the bay, and space is a premium. That's something I hear quite a bit at most facilities. The discharge treatment rate was 2 CFS. So what's the big deal there? Well, as far as treatment goes, that's a relatively large treatment flow. So that was a challenge. the owner was unconvinced of the effectiveness of other treatment products, and most of the alternatives were above grade, and that was an issue when you're maxed out on space. The solution, again, perform the pollutant removal testing. That's, again, step one for me. We take a representative sample, send it to the Portland lab to determine which product meets the requirements of the effluent. And Up-Flo filter proved to provide the peak performance on this. The outcome, the removal ranged between 80 and 97%. We met all of the NALs for this facility. So all the metals and TSS. The owner was pleased, loved the data, and also loved the fact that the Up-Flo filter was an underground system, didn't take up any ground space. So below grade, saved land space, required absolutely no power, no operating guidance other than some maintenance, reduced the capital cost compared to all of the other solutions that were presented. So this was a win-win solution for the owner, that he saved ground space, he saved money, and it's a great application. So the next thing I'm going to bring in, I'm going through this rather quickly, but the next one I want to bring in is chemicals. So we can use the coagulants and flocculants, and this is just an example of before and after with the use of flocculants. It's pretty eye-popping when you see these things at work, which you actually will. So coagulants and flocculants. The first thing is, what are they? They're chemicals that force small particles and sediment to clump together so that they can be removed much easier. They sometimes can float and they sometimes can sink. We like the ones that sink. And you see the downstream defender to the right. If you forgot what it was, that's one of the products I initially discussed. That system would not be able to remove a lot of the particulates on a site because they're too small. So it would go right through the system. Smaller particles, that is. So we'd use coagulants and flocculants to help it settle it out. So why use them in a treatment application? Because separation alone won't do the trick. And many times the particles are so small, they can go through many filters and many membranes. And so that's another reason that you'd want to use chemicals. And the last one I could think of is that the load is so heavy that it could create a maintenance issue for something you have that actually does the polishing treatment. So that would be another reason to use these. And that's kind of like construction site runoff, which I'm not really going to get involved with, but often used coagulants to knock down just the incredible load of sediment. So what's the difference between a coagulant and a flocculant? Turns out there's really quite a difference. A coagulant essentially is something that has a charge, and it neutralizes the charges. So this picture shows clay. So they're negative to negative charges. Think of them like magnets. The same polar part of the magnet repels each other, and that's exactly what happens with particulates. If they're the same charge, they repel each other, and basically that can keep them suspended in water sometimes for years. So they're really hard to remove. And this also mentions the submicron particle size. So essentially, adding a coagulant changes the charge, and it's sort of like changing the particle. Whereas a flocculant is more of an agglomeration. It's a process that it comes in contact and adheres the particles rather than changing the charge. So, and these are typically larger than 1 micron. There is possibility to go lower, but essentially this creates the flock. Now, often they're used together. You use the coagulant to change the charge. You use the flocculant to conglomerate everything together and flock it out, which is commonly a common word. So that's the difference between a coagulant and a flocculant. There's lots of other differences, but in my mind, the coagulant changes the chemistry. The flocculant doesn't. Now, there's 2 types of flocculants, anionic and cationic. We use anionic only. So, and anionic is a negative, kind of a negative charge flock. Cationic is a positive charge flock. The difference is cationic, if it escapes the job site somehow and it gets into the river downstream or receiving water body, it can stick to the gills of fish and create fish kills. So you have to be a lot more cautious using cations as opposed to, or or anionic. So I'm going to show you quickly what it looks like to use a flock. So focus on the two cloudy systems. What you're going to see when you're doing a flock, there's three things you look for. There's contact time with the flock. There's mixing time with the flock, and then there's settling time. So those three parameters, we have to figure out what works best, and we do that in our lab. So what you'll see is a solid flock being entered here. I'm going to start it, but you'll see a solid flock being entered into the system. We call it a flopsicle, by the way. So here they're adding the flopsicle in. So this is the contact time of the contact of the flock in the water, as well as mixing. They kind of usually take place simultaneously. So we'll leave the flock there for a certain amount of time, then pull it out, then turn off the mixing and watch it settle. This is actual stormwater from a facility. You can see it flocking there. Now we'll turn the mixing off and let it settle. And it's pretty amazing, you know, when you show an owner that this is your before water and this is your after water. Just totally amazing. So we've done a lot of this test. Sorry if I cut that off, but I'm going to move ahead. Through all this flock testing that we've done, we found out that, you know, if you put the mixing time as a horizontal portion and the settling time as the vertical, you can see that the settling time has a very large impact, more of an impact than the mixing. And what you're seeing is what we tried to do is figure out a way, how do we improve the settling time? And that's one of the things we've done. Here you can see we have a downstream defender here, and that's what we've used to improve the settling time. So in a flock application, I'll describe the whole thing. So this portion right here where my arrow is, that's where the flock is entered. So this would be a solid flock application. It's being pumped up from I'll call it a detention system or a storage area. The flock is added here, so you have flock being added, the contact time, and through here you have mix time, and into the downstream defender is essentially a settling time or clarifier, and then clean water is exiting and going back into the drain. So that's a typical setup for flocculants. This one obviously uses a pump. I have a case study where it was strictly gravity, which is pretty amazing. So the background on this one is, it was a facility on a river in a very congested city. And it was cement aggregate, so they had a great deal of concrete dust entering their stormwater. Dust is, you know, that's extremely fine. All the drains completely clogged, surface runoff only. The sewer district officials often, there's a sewer train that goes right by the facility, and they notice a plume in the water. And others noticed the plume as well, right in the river. And so this owner, when the sewer district saw it, they mentioned something, and it, you know, obviously puts the fear in the site owner that, hey, we've got some exposure here. There's a possible lawsuit or maybe even some regulatory action. Sometimes I'm not sure which is worse, but typically the lawsuit is much worse. But anyway, so because of that, it kind of drove the project. So the challenges, well, on the right, you see a picture of the site. And I think they excavated the drain, which is right here in the lower part of the picture, just for me because I was coming that day to look at the site. And that in the background is the aggregate recycled material. And on the side, you see a different recycled particle size. So the drain is completely plugged. All the drains are plugged. Probably some of them have that pile on it. And that pile can go, you know, when I arrived that day, I think it was about 100 feet high. So it was huge. The pH, because it's cement, was very high. It was 12. And what's the, you know, I'll explain what the pH concern was. And as usual, minimal land space. So we had to, the real kicker was we had to provide the solution under $40,000. So In my mind, that limited it to one thing only, and that was chemicals, because a filter, any one of my filters would have been more expensive to do the treatment. The other kicker was it was a repeat client, so you hate saying no to a repeat client. And the only thing he asked me for was clear effluent to stop the plumes. So I took that back. Pardon me. I took that back to our hydro lab. We used the water. In fact, you saw the water in that flock test with the flock sickle. That was the actual water from this site being tested. We evaluated the clarity each time we did a bench scale test. So I mentioned pH. We had to find a flock, a solid flock that could operate with a pH of 12. So we did all this on a bench scale design, and then we scaled it up to 200 gallons per minute. That was the required treatment rate for this site. With this site, we did it with no power. There was no mechanical mixers, no pumps. It was a gravity system using pipe, static mixers, swirl technology being the downstream defender, and minimal footprint. And I'll show you sort of what I got from our lab. So when I brought this into the lab, this is what I was given back. Okay, you need four blocks you see the 4 squares there. Those are supposed to be solid flock. So 4 pieces of flock in a 60-foot pipe. That gives me my contact time. I need 45 feet of pipe with 2 mixers. The mixers are actually in the pipe joints. So these 2 mixers at 45 feet give me the mixing time I need. And then I use the downstream defender, an 8-foot downstream defender at the end, to settle all this out so we could discharge clean water. So this is what comes from our lab. They bench scale it. They size it up to the real world for 200 gallon per minute treatment. And this is what you get. So these ports you see here, some of this is in the active area, some isn't, but for the most part, these ports are the flock location. You can see the flocks in here. So this is the contact time for the flock. This pipe provided the 60 feet of contact time, 45 feet with the mixers into the downstream defender that swirls and settles all the sediment out. And then it discharges from here, would discharge directly to the river. So it's a simple application. The outcome, we reduced the turbidity and TSS by 95%. So the water was very clear. In fact, you saw it in the very beginning. So it was even more clear than the river water. So we took care of that turbidity issue. We treated the discharge, so the visual quality eliminated the plume, and as an added kicker, we removed a great deal of the metal constituents up to 93%, and this system was under $40,000. So that gives you an idea of what we can do given a fantastic lab to work with, and the ability to bench scale something in the lab, size it up to the field instead of, I mean, we do have to tweak it in the field, but for the most part, the science is already worked out when we bring it to the field. So this was just an amazing application. Another one would be I was not involved with this one, but this was a case study of the Russian coal mining facility. You can see it here on the map. It was very close to Sweden. Essentially, this was a heavily industrial facility, chemical processing, mining, coal. And the problem was coal dust was, if you've ever dealt with coal dust, it's nasty, it's black, impacting the rivers. And they were being pressured by border countries and essentially, we'll call it the world, but to improve the environmental conditions of the river. So the challenge was, the river's been suffering from coal dust. Dust is really challenging to remove, coal dust that is, because it's got such a low density. And sometimes it can float, sometimes it can sink, and it can be an extremely small particle. So Hydro used our lab, not the Portland main lab, this one was done over in the UK, essentially did a lab analysis and tried to understand the pollutant load to determine what we needed. And what we needed was a coagulant and flocculant in this application. A little bit differently, the coagulant was a liquid, so we did have to pump. We actually had to use mixers. This was a little bit more advanced than the system I showed you that was gravity, in fact, more advanced. And these, to be done properly, they have to be done with advanced processing perhaps a PLC unit, a programmable logic control that can control temperature, the flow of flock, the pH of the flock. All these things can impact the flock. Not to get off course here, but they use the downstream defender to capture, to do advanced, or I should say, to do pre-capture of the flock, and then they use the filtration device because I mentioned you don't want coagulants exiting your site. So that's essentially how this system was operated. And you can see here the downstream defender, it captured 95% of the coal dust. You can see the pictures here. The first one's the influent using the chemicals on number 2 through the downstream defender, capturing the chemicals, and then 4 flew through the Up-Flo, literally pure. So I'm going to do a poll here. This is I'm going to be a little bit faster on this poll, so I don't mean to cut you off, but I am going to launch it right now. Essentially just wondering if you're aware of other facilities in your neck of the woods that might be adding pollutants. So go ahead, the poll is open, vote. I'm going to give you about 10 seconds to do this vote, and then I'm going to close it and end the presentation here shortly. All right, looks like everybody's voted, so I'm closing. And I'm going to share the presentation with you. And there you see 29% yes, they know, 45% no, and others aren't sure. And that's not, you know, being unsure is, you know, you don't know what's going on behind fences, and it's not like these things are publicized. And in fact, you know, industrial facilities often try to keep things very tight and secret because, you know, there is a threat of lawsuits, so they're rightfully so doing that. I'm going to hide this and continue on. Just want to talk about maintenance quickly. Hydro does offer maintenance throughout the country. You know, we design these systems, and it doesn't matter if it's our system, a competitive system, a pond, a catch basin, could be anything. Just wanted to let you know that we can essentially come in and maintain anything. We have all the right tools. We're very familiar with the competitors' systems as they are with ours. And not only that, we can train your in-house staff to do their own maintenance if that's what you'd prefer. So, you know, we offer this across the country. We also do inspections. We do inspections to, hold on one second, please. Just want to, at any rate, I've got to move on and finish here. The next steps, what are your next steps? First, I want to say you constantly make progress. If you're making progress, the chances are less likely for you to incur legal and financial penalties. Some of those penalties, go to bullet number 2, is $32,000 per day. That's a lot of money. Nobody wants to face that. Not only that, you have to correct your system. If there's legal action, a lot of times what you're going to do to correct that action is taken out of your hands. And that's a very difficult situation. Last thing here, waiting to take action could cost you money, and long term it could cost you using the proper system, because you might be dictated to as far as what system you have to use. So essentially, don't overdo it, don't pay more than you should, and don't underdo it. Don't use a catch basin insert when you need an actual filtration system. Not that they don't work, they're excellent. They're, you know, and one last thing I should note is, because you put in a treatment system doesn't mean you don't have to do typical maintenance either. You have to keep that up as well, housekeeping that is. So your final step here is what I would urge is you should order a pollutant removal test kit from us, and you know, take your site runoff, send it to our lab. This is free. We do this for free, you know, to determine if our products will actually work for your facility. And that's the bottom line. We want to prove that our systems can work before we put in a treatment system for you. It doesn't benefit anyone to have a system that has issues going in. So rather than troubleshoot it in the field, we like to troubleshoot it in the lab, prove performance, and send it to you. We'll send you the actual results, show you what the test, what the influent and effluent results are, and you decide if this meets your site requirements. 9 times out of 10, if we have positive results here, we have a positive outcome. So there is I want to mention again, there is a webinar, or excuse me, a survey to take at the end of the webinar. So if you don't want to win $50, that's fine. Please take the survey anyway. I know you can see the poll survey information on the screen, but I am lacking the information how to shut it off at this point. So I just want to mention, if you take the survey, there are going to be some winners of the $50 certificate. You'll be notified this week. PDHs will be sent out no later than tomorrow. But I can't stress, please take the post-webinar survey. It helps us, it helps you. And with that, I'll say thank you. If you need to reach me, my number here, the cell number, you can reach me anytime. I cover across the US and Canada, 786-350-8819, or you can email me. I'll welcome your calls and love to help, even if it's a simple thing as maintenance, housekeeping, anything you need help with, I'll try to help you. I appreciate your time, and thank you for attending the Hydro Industrial Stormwater Treatment webinar. Have a great day.